Let's go. Yeah. I really got the feeling today that everything is going my way. Now this is what I'm talking about. Every time I see your smile, it makes me shout. Let's go. Ah, let's go. Nothing's gonna stop us today. Get on the bus or get out the way. We're cruising with the radio on. So turn it up to 10. Here comes our favorite song. Let's go. Ah, let's go. Let's go. Ah, let's go.
Hello and welcome to another thrilling episode of IoT Tuesday. I am yours truly, Samuel Latrani. Good morning, good afternoon, good evening, potentially good dawn, wherever you find yourself on the continent. This is your one and only show that gives and demystifies IoT on the Microsoft Azure Cloud and other services to you. In today's episode, we're taking off from where we started last week, where we're trying to connect the Raspberry Pi to send some telemetry or to send some sensor data to Azure IoT Hubs. When we come back, we're going to take it from there, and then I will give you some bonus into something I'm working on. Stay tuned. Awesome. Okay, so as you know, before we get started, I always bring you some updates on what's happening. The first thing is that if you're watching me from YouTube, you might probably potentially have some issues as Restream, the service I use for my multi-stream, is having some challenges with I think YouTube and Mixer. So there might be some problems there with Mixer YouTube stuff going on. So please bear with me. It looks like not all the portals are getting the update, so bear with me, and then let's bear with Restream for fixing that. So before we get started, or we continue from where we left off, I want to show you something I'm working on. So for this one, credit goes to my wife. Yes. So with all this COVID-19 craziness thing going on, I think she saw something on social media and came to me and said, I want one of this. I want you to build me something like this. So what is this thing that she wants me to build? So if you've used these automatic dispensing, faucet or taps before, that's a similar thing that she wants me to do. So now with this whole COVID issue where people you're being asked to wash your hands and that flowing water and all that, there has been a trend happening in Ghana right now where people are buying something we call Veronica buckets, which just basically just buckets, plastic buckets, and then they are fitting taps in these buckets. So they pour a mixture of soap and something in the water, and then when you come in, you can open the tap and wash your hands. In areas where water flow, it's a problem. So she wanted me to take it to the next level where you don't necessarily have to touch the tap or you don't necessarily have to touch the soap dispenser. And she just wanted me to come up with a solution. So this was day before yesterday. So I quickly went into my box to look for some things, and I'm going to take you to the bench to show you what's happening. So here we have a prototype of what's going on. Um, so first of all, let me show some things here. So this is a battery pack. This is powering the whole thing that I'll be building. And the key component in all I'm doing is this. If you can see this, let me actually put it here in the camera so you can see. Take it close, take it close. Uh, I'm trying to let this actually focus properly so you can see it. Yep. So this is an IR sensor. So it's actually used in obstacle avoidance, building of, yeah, basically. So one of it is an infrared transmitter, and the other one is a receiver. So when the beam is shot, what happens is that when it hits a certain obstacle, that beam is reflected back to the receiver, and they can tell if it hit an obstacle. Now it has a potentiometer on board that allows you to tweak the sensitivity of how sensitive, or as to what point it would say that this is an obstacle. So I put this together, and I have something on my workbench. So if you watch closely, if I just bring my hand close to it, as you can see, this servo motor here has actually been flipped, and it's going to open for 5 seconds. Now after the 5 seconds, it's going to, as you can see, go back to it. So let me do that again. So if I just put my hands there, so the idea is putting my hands over it is going to signal that I have my hands under the tap. And once my hands goes under the tap, this servo here is going to open the tap. So if I do it once again, as you can see, it moves around. Now, the whole concept is, so I'm going to bring, so assuming there's a tap, all right, let's bring this here so you can see it properly. And then I put the sensor somewhere here. Let's do it this way. Okay. I'm going to, because this is supposed to help you understand, I'm going to do this. So let's say I have this somewhere here, and permit me to do this because I'm taping it here so you can see. So something like this. I hope you can see this. So which means that now if you have something like this and I put my hand here, it triggers the servo motor, and then it opens. So now water is going to flow for 5 seconds, and I can adjust this in code for 5 seconds, and once that is done, as you can see, the servo goes back. Now the challenge I've been having for a couple of hours in today was that, now when I went out, we have the bucket, but all the taps have been sold. I couldn't find a flexible tap to use because this servo motor, I am worried that it wouldn't have enough torque to actually, push this. So the next thing I'm going to do is that I'm going to try to connect this servo motor. Let me just bring it somewhere, some way, somehow, either on top or the side or something that can actually, change change the direction of this, either this way or that way. All right, and I'm not sure the servo motor has a torque to do that. If that doesn't work out, the next thing I'll do is that I'll actually use a pump. I think I have one here, either a submersible pump or something, and then when I do this, that triggers a pump to start the water to flow, like to pump the water from the bucket into this. So that is just an insight into some of the things I'm working on. If it sounds interesting to you, just follow me on any of my channels down there, or just give me a head up, and then I would help you, or I'll walk you through it. Now, the same concept can be applied to dispensers. So you could just do a contraption and put it in, and when you hover your hands over it, it actually hits the top of the liquid dispenser, and that's going to dispense it. Different ways you can approach it. All right, so that is what I'm working on. Now let's get into what we're going to do today. So to do that, I am going to bring my Visual Studio Code. So if you were following last week, we connected our Raspberry Pi. We set it up in the last one, and then we used it to kind of like automate and control a few things, a few sensors. Let me move this here since we're not using this now. And then let me bring in view. Actually, yeah. I just want to bring it in view so that you can actually see this. Hopefully, I don't disconnect anything. Okay, cool. Let's leave it that way. I'll come back to it. So, we connected the Raspberry Pi, we set it up, and then we're able to, send it, like, collect sensor value. And I was doing this remotely through Visual Studio Code. So here, as you can see, it's asking me to connect to Visual Studio Code, which I am doing. And now this has connected to the Raspberry Pi. So if I switch to the bench, as you can see some form of yellow light going on. That is because I am currently running an LED code on a Raspberry Pi. So I created the full screen as I mentioned, so that you can see me, you can see my. So what I'm going to do here now is actually, let's go to LED. Let's open the LED, and I'm going to zoom the LED. Yeah, so that you can see, so that you can see the code. Let me close this and close this so that you can see the code properly. Yep. So as you can see, you're seeing the four screens here. So this is obviously me in this side, and then you have the workbench where the LED is, and then the code on the other side. So if I run this code at the moment, oh yeah, this is happening because of the type of the version of Python I'm using. So let's do this. I'm going to call Python 3. This is LED. No, this, yeah. Let me call the LED first. So LED.py. Okay. So now, as you can see, where did I throw that? Yeah, right here. So as you can see from here, you can see that the LED is blinking. It's turning on yellow, and then it goes off yellow. And if you're looking also at the top, that be top left, you can actually see the output of the code that is making this go on and off, as you can see. All right, so quite very simple out there. On and off, quite simple. So currently, this is just showing you how to run the code in Python. Now, for the interesting thing, I'm going to actually stop this, and I'll close this. And this is quite simple, very simple. Now, let's open the code we're going to use today. I'm going to walk you through the code first, and then when I'm done walking through the code, I'll come back to it, and then we'll see how that works. All right. So let me go through the code. So this here is the code we're going to be using to send data into Microsoft IoT Hub. So the data from let me just run this quite quickly. So what I'll do is that I'm going to yeah, that's fine. I'm just going to go through the code. So this Adafruit DHT is the library that allows me to get the sensor value from the DHT sensor we're using to collect the temperature. Okay, that's one. And then we're running it in async mode. That's why we're importing the async IO library. And I'm using a timer because I'm trying to do I need a timer to set intervals on when data is sent. Okay, and then we're using JSON because I'm using this library to help me send JSON to Azure. That makes it a lot easier. And then GPIO, RPI GPIO, this is the library that allows me to have access to the GPIO pins on the Raspberry Pi. Quite very simple. Now, this here, this is the whole source. This is the magic. So if you're working with Azure IoT Hub, you need to use the library from the IoT device libraries. So this allows you access the IoT Hub, has all the methods and functions or whatever you want to call it you need. Now down here, what we are saying is that our temperature and humidity sensor is on GPIO pin 4. So let's go back here. Let me show you that. So I wish I could take this a bit. Okay, let me actually do this. Let me bring this a bit closer. And yeah, because of the light I am using, some of these things, like it's very bright. So I'm just gonna just move this a bit here, just so I can show something here. Okay, so right here, as you can see, yeah, let's bring this back here and get this going. Okay, we don't technically need the Raspberry Pi itself, as it's already giving us the data we need. Okay, so here, this is a temperature and humidity sensor, okay, which is connected to pin 4 on the Raspberry. This is a yellow one connected to pin 4 on the Raspberry on this side. The light is also connected, the LED is connected to pin 18 on it here. So that's pretty much it. Now let's go back to the code as I explained so we can run this. So um, once the pin 4 is defined for the sensor, I am saying that the sensor is actually a type of what? DHT11. That's what I'm doing here with this line. And then I'm setting it up. Now the GPIO, you can have different modes. You can have what this mode means is that are you going by the GPIO pings as they are on the board on the Raspberry Pi, or you are using as the cobbler? And the cobbler is BCM, which is standard, so that's what I'm using. And the LED, obviously, like I'm saying, I'm setting it to pin 18, which is connected to pin 18 on the Raspberry Pi. So we've set it up as an output, and yeah, there it is. So here, this is a function I have written that allows me to toggle between turning the light on and off because I use it within the functions, or in the application. Now, I'll talk about this later on, so I can just close this when we get there. Now, this is the main method or the entry point to the application. Now, to connect to the Azure IoT Hub, you need to have access to your connection string for the IoT Hub. And this is not a best practice, but I've exposed a string here, and I'll show you right now in a bit. I'll go to the Azure portal and show you how to get this. Now, once you get the connection string, thanks to the library, the IoT device library here, we imported the what? IoT device client. It is an IoT device client that allow us to interact with the IoT hub. All right. So with the device client, this is what we did. So I said that I'm creating an instance of the device client, and then I'm creating it from connection. Okay. So here I am creating IoT device client dot create from connection string, and then the connection string is here. All right, right from the what? From the connection string I got it. So now let me show you how I got the connection string. So if I should come here and open the Azure doc, open my subscription. Now I have already gone ahead and connected my Visual Studio Code to my Azure subscription, and within my Azure subscription, I have created an IoT hub. All right, and this IoT hub is what we are using. So as simple as when I go into this IoT hub, I can right click and look at the properties of the IoT hub. All right. In another way also, once I do that, now take a look at this. You can see I see the properties of the IoT hub all here. And then because this is just read only, I don't have access to, all the other info, but I'm going to go out into, let me open another instance of Visual Studio Code. Good. Okay, so this Visual Studio Code here is not connected to how do you call it? It's not connected to the remote. It's not connected to our Raspberry Pi. So I'm going to reduce this, and I'm going to go to Azure, and this is going to open up all my Azure services that I have, and then IoT Hub. I'm going to refresh, and it's still connecting. So as you can see, the little progress bar showing here. So I want to show you how I got access to the connection string. I can do it from right within Visual Studio Code or from the Azure portal itself. But I want to show you, since we're working from within Azure portal, Visual Studio Code. I want to show you how to get it. But with that also, let me. Okay, so this opens the subscription. I open it up, and then it's going to open up my. It's going to open all my subscription, all the things I have. Yes. I have my antivirus warning me of, yeah, I know, that's fine. Okay, so this is my IoT hub, right here. Okay, I have all my IoT hub showing here. Let's see. Yeah, remember, allow it to connect. Because once it connects, it's going to open that up for me to see all the stuff. And it's just a matter of me right clicking on it and then looking at the connection string. Don't know why today it's okay. Let's do that from the portal. So let's go ahead. portal.azure or asia.com, whichever way makes it easier for you. Oh, see how I spelled it? I was spelling something very funny and crazy. All right, so let's go into our Azure, and once that's going, I'll just, out of curiosity, I'll just go back to check if it's loaded again. Nah, it's not. Okay, so all right, I'm gonna log in, and then I'm going to go ahead and put my super sensitive password. Okay, with my super sensitive password entered, let's open up and see what we have. Awesome. Welcome all of you. We're talking about connecting Raspberry Pi to Azure IoT Hub and reading sensor values. So we're using the IoT Tuesday IoT Hub. Now, if you don't know how to create the IoT Hub, I have previous videos I have done that shows you how to create an IoT Hub. Just check out my channels and you have those informations at your disposal. Information at your disposal. Okay, so if I go here to public key and access, ideally, I'm not supposed to show these things, but I'm going to recycle all of them once after that. So you can see that, let's see, if I open the devices here. So once you create an IoT hub, you need to create your devices. So if you look closely, we have actually added the Raspberry Pi as a device to this IoT hub. All right, and that's it. You can see the Raspberry Pi. So I can open the Raspberry Pi, and with the Pi open, I can now see stuff about the Pi. Okay, so and here, so these are the keys. So I have the primary connection string and the secondary connection string. So this is where I copy the connection string from, and then into I bring this here into the code. All right, so that is how I got the connection string. Now, with the connection string, I actually created an instance of the device client that now would allow me to communicate with IoT Hub from within my code or from within the Raspberry Pi. Okay, now there's the case for Node as well. So if you want to do JavaScript, C++, you can have the libraries there. And then now I connect to the device client. So with this device client, I now have connection to my IoT hub and I can now send data to the cloud. So I've created two variables here, last temperature and last humidity. Now I was using this to check something. Now this is because if you create the IoT hub and you're using the free tier, you have up to I think 8,000 messages in a day. All right. So if you're looking at if you don't have a mechanism to utilize that 8,000 and you decide to say I'm collecting sensor data every 5 seconds, you do the math. All right, you're going to exhaust or blow out the whole of your location really quick and fast. All right, so that shouldn't be the case. So what I did here is that I'm using this last temp and last humidity to actually check if the temperature and the humidity hasn't changed before the last data was sent to the IoT hub, there's no need to send the data. But then if it changes, okay, if the data changes, then you can send it to the IoT hub. So let's do this. I'm going to modify the code a bit just to get the temperature because I realize the humidity doesn't really change that much. So here's the code. So while true, and this is how using the Adafruit library we are getting. Let me bring this up a bit and actually close this. Yep. Yeah, so with this line of code, what we're doing here is that we are actually getting the temperature and humidity sensor data from the sensor. All right, so now I have humidity and temperature all there. Now, if there is no data, if I have data, so which means if the humidity is not null and the temperature is not null, which means I have data, I am printing the temperature and then the humidity is, putting the humidity there, and I'm formatting it nicely for me. Now, this is where I'm checking if the temperature has changed. All right. Now, so to make this much visible for us, I am going to get rid of this end so that it's only the temperature I'll be looking at. Okay, I'm going to save this. So, yeah, so let's do this now. So simple. So I'm saying that if the temperature is not equal to the last temperature, and if you look at it, I've set the last temperature to 0. So if the new temperature recorded is not equal to the last temperature, which is 0, then we set the last temperature and humidity, and then I create a JSON object that has a temperature and the humidity. And then look here, I now use a device client to send the message to the cloud or to Azure IoT Hubs. All right. Now, for the sake of the demo right now, I'm going to all the code pieces that I'm going to take out the twin. I'm just going to take out this twin for now because I will, or better still, let me just leave it there and I'll just comment it out. And then I'll explain it later on. So let's save this. Okay, so cool. So if the temperature doesn't change, but this look, if you look at this code closely, it doesn't mean that I am not writing the temperature values. I'm showing the temperature value out, but then I'm not sending it, okay, to the cloud. All right, this is it. I'll print the temperature value right here, okay, but I'm not sending it. So which means I am being smart about how I utilize my messaging quota. So I'll only send data to the cloud or to IoT Hub if the temperature has changed. All right, if the temperature doesn't change, I won't send it. So it's only when it changes that I'll send. So then I have a way to maximize my intake. So now once I'm done, I connect it, I disconnect it, and we're done. So let's run this and let's see what we get. So because we're going to run this, I'm going to open this up, and then we'll do Python 3, and this is dht11.py. So oh, see what I did. I guess I can spell again. Okay, so now it spins it up, and now look closely. So here I'm saying that I'm going to go to the code a little bit so I can explain it. So here's it. I'm saying that I'm printing the temperature, but then if it changes, before I send it, I'm printing sending message. Okay, so let's say sending message to IoT Hub. Let's save this. And then for the sake of the show, I'm going to stop this. And then I'm going to run it again because I made changes to it. Okay, so now let's check this out. So when we start, the temperature is 0. So as you can see now, the temperature is 25. All right, temperature is 25. And because temperature is 25, oh, hold on, let's see what's happening. Oh, okay, so yeah, so now the temperature remains the same. Okay, so nothing really different is happening. All right, so nothing really is happening. So it's either the sensor cannot read or it's reading 25. So at this point, nothing is being sent to the cloud because the last temperature was 25. All right, so you realize that now nothing is being sent to the cloud. Now for the purpose of this, I'm going to go in here and let's go to the devices and let's look at the messages. Okay. Yeah, that's fine. So let's open this up. And which one did I use? Ooh, this is strange. Okay, let's see. I'm going to create a new one right now. So let's call it IoT Tuesday. All right. Well, let's just keep it here. It's a general purpose standard. I'll say locally redundant, that's fine. Yeah, yeah, okay. So let's submit this. Okay, so while this deployment is in progress, okay, no cancel. Okay, it's validating. Well, so let's go back here while this is happening. So as you can see, all right, the temperature is not changing, all right, and you can see that I'm not sending anything to the IoT hub. Look at the first thing I sent. The temperature changed 25, and I sent it to the IoT hub because the temperature changed. Apart from that, I am not sending anything to the IoT hub because I'm preserving it. Now I just want this to be done so we can look into it. Still validating. Still validating. Okay. So this allows me to, you know, this allows me to, you know, save some messaging. Now, to simulate this, I'm going to do something to increase the temperature a bit so we can see if it's going to send it when temperature goes beyond 25. So I am going to, so I have here, I have a Dex soldering iron. I'm going to push it to quite about 450 degrees Celsius so that, yeah, it can be hot. So whilst that is happening, another way would have been to use a blow. Okay, so still 25. So what I'm trying to do now is I'm trying to increase the temperature in the room, or just bring something hot to the sensor for it to feel. So okay, how about I'm just like rubbing my palm, and then I'll try to touch it and see. Does that change that? Okay, the humidity changed, but the temperature didn't change. Okay, no problem. I'm heating up. Let's see. Okay, so what I'm doing now is I pick the sensor and I'm putting it in between my palms to see. Okay, yeah. So see what I did. So all I did here was to put the sensor in my palm just to increase the temperature. And do you see that? So now 26, 27. All right. It's sending it to IoT right now. Okay. So now this data has been sent to the IoT hub. Quite simple. All right. Very simple and straightforward. So now let's go back to, let's see if our provisioning is done. Okay, it looks like it is done. And where is that IoT Tuesday? We don't have a container here. That's fine. Okay, that's fine. Okay, all right. So I'm not creating a device twin. Let's run this and see what we have. Okay, all right. Okay, so all this data now, the data now has been sent. Let's see. Do I have any jobs? No, we don't have any jobs that we have done. So this will not give us anything, but we have our data, all right, in there. Now, the next thing I want to talk about here is the concept of device twins. Okay, the concept of device twins. So now we've seen how to send the data to IoT Hub. Now the question is that how do we send commands from IoT Hub to the device? So that brings the concept of a digital twin. So what a digital twin is just like a representation of your device in the cloud and has something called a desired state. So the digital representation of your device in the cloud with this desired state allows you to ensure that the state of a device in the cloud matches the physical state, wherever you put it. So let's say as an air conditioner, you would have a digital twin or digital version of that air conditioner in Azure IoT Hubs or on Azure IoT Central, and you say that at all times I want this air conditioning to be running at, let's say, hypothetically running, let's say, about maybe 60, 70 degrees Celsius. All right, that is a desired state. So as the sensor is reporting the temperature to the hub, the digital twin can also infer. So the digital twin is sending its data. So if there is a difference between what the twin is sending and what the sensor is reporting, automatically you can write code, all right, to change the value, of that air conditioner in our case. So to do this, let's go back to the code here. I'm going to stop this, and then I'll explain. So here, as of now, we're only sending the data. Now, anytime, okay, now anytime data is sent by the client, it also reads the digital twin information. So this is where I have this whole twin info. All right, this is where I have the twin info. So I'm creating the twin here, which is actually the device client.get twin. So anytime um, a temperature reading is sent, or a temperature ID is received, I am reading or getting the twin value from IoT hubs. And then once I do that, I am actually calling this method to handle the twin. Now let's take a look at the handle twin. This is the handle twin. So here, this is what I was talking about initially. So anytime I'm sending data, anytime I'm sending a sensor data, I am here I'm getting the twin value from IoT Hub. And then I'm calling the handle twin to handle whatever information is coming from the twin. So this is the definition of a handle twin right here. So all I do is that I'm printing, I have received a twin, and it is checking if the twin has something called desired state, desired property in it. All right, then we check if it also has an LED in the desired object. All right, what do we want to do? Depending on that LED value, we want to use that LED value to toggle the LED. And to toggle the LED, you can pass true or false, 1 or 0. All right, to turn an LED on or off. So this is what we do in our case if we receive a twin value that is coming from the IoT hub. So this could be a twin value that is supposed to be a desired state. We can compare that with what we have and then do something else. But in our case, we are only turning the light on and off based on the information coming from the IoT hub. And that is what you might turn cloud to device. All right, so let's see how that works. So look at it. First, it checks if it has what? A twin. Okay, if the twin has desired in it, desired property, and then if that desired property has an LED property in it, and then if it does, what is that value for the LED? We are using that value to turn on or off an LED on our bench right now. So let's take you here, and let's go to the IoT hub, and let's go to devices. Every device will have their own twin. And then if I open the device app, we have our Raspberry. And then if you look here, there's device twin at the top here. All right. Let me zoom this so you can see. So if I click on device twin, all right, this opens up the device twin for our Raspberry Pi. Check that out. So this is the device twin. Okay, open this up and then look closely. It has what? In the properties, it has what? Desired right here. And then it has an LED of what? LED value of what? 0. And if you go back to our code and you look at the LED, toggle LED function, it takes a state. So 0 or 1 or true or false. So 0 means off, 1 means on. So here it's saying that if there is an LED in there, put the LED value into an LED state variable and then use that variable to toggle the LED. So if it is 1, it means that it would send data from the IoT hub, and then this Raspberry Pi would act on the data coming from it. So let's test that out. So I'm going to save this, and then we are going to run this again. And then we're going to run this again, and then now I have actually preheated. This is quite hot. Okay, please don't try this at home. Okay, this is quite hot. Don't try this here. So let me do this so you can see it much more. So I'm just taking this Oh, let me do this so you can see the entire screen. Hopefully you can see the temperature readings there. So I'm taking this closer and this should send the value. Okay, there you go. I can already see that it has sent the temperature value of 26 there. All right, it sent it 26. And then if you also look closely, all right, you should realize that it's also responding with a twin received. And as you can see, the LED state is 0. Now, the LED on our board here is still what? It's off. All right, because the LED state in the twin desired property is 0. So now let's go here, and then I am going to change the LED state to 1. Right, I just changed it to 1. Now click save. Now let's see what happens here. That if it receives, now look at that. Now the LED is on. Now sorry, because of the lighting in my studio, you don't really see it there. So let me hide it. Let me actually bring it a bit here so you can see. Oops, I just disconnected the internet. Yeah, connected that back. So now you can see that the LED is on here, right here. The LED now is on. If I should go back to the device twin, all right, and then change the LED value here to 0 and save this, now it's going to send this to the device, to the Raspberry Pi. And the Raspberry Pi, as you can see, the LED is off because it read the data coming from a device twin and it acted upon it. So a typical scenario would be, like I mentioned, the air conditioners. If you have remote, if you're managing air conditioners remotely for an organization or a building, you can use a design state to tell it that this is the temperature we want all the air conditionings to be running on. So if the data coming in, all right, if your Pi or your smart device is reading that value and realize that that is not the same as a value of something it has to do, then it's going to what? Tweak that and turn it on. So another example would be as you're sending the sensor data, you can send it to an Azure function or something, and that's going to determine is it an ideal value. Let's say the weather has changed and you want to automatically regulate or control the air conditioners in the room. Now you can say that because of the data you received, you want the device to change the value of the air conditioning to a particular value, and then that could change. Now, in the device twin, you can put a lot of things. Here, I could put, I could put different things, different values that the board or my Raspberry Pi can read and act upon to manage a lot of things. So that is how easy it is to connect your Raspberry Pi to Azure IoT Hub. In the next episode, what I'm going to do is that now we're going to see how to visualize that data. Because now that we've seen how to connect to IoT Hub, maybe we should do connecting it to IoT Central, because IoT Central has a dashboard. But no, first of all, I'm going to show you how to take this data, to act upon this data. Now, as the data comes into, this hub, what do you want to do with the data? Do you want to do some analysis? Do you want to? So we're going to use a flow or a logic apps, all right, to act upon the data that comes. Or we can use the flow that as the data comes in, we're going to collect that data and store it into a database or put it in an Excel file or do something, whatever we want to do to it, or tweet it, all right? So next episode, I'm going to show you how to do that one, and then we're going to see how to now connect it apart from the IoT Hub. Remember, Azure has a lot of IoT services. We've seen how to connect to the IoT Hub. Then we're going to now see how to connect to the IoT Central, create our template, and deploy a lot of applications. And then we can now plot our graphs and everything based on the data coming from the Raspberry Pi. So in next episode, we are not going to only use a temperature and humidity sensor. We're going to connect a fan, a relay, and all that. And we can see how we can send data from either the IoT Hub or the IoT Central to control and show the fans. And then we're going to have some fun in, either tweeting the value or, changes happening, whatever we want to, just have some fun with it. So that is all I have for you in today's episode. If you have any questions, if you have any suggestions on something you want to see or something you want me to do on the show, just send it to me at @sadranyi on almost all the social media platforms. That's my handle. And let's connect, let's have fun, and learn some new things. Until then, this has been Samuel Adrenyi for another very exciting and simple episode of IoT Tuesday. Stay safe, maintain your social distance, wash your hands, keep clean. I mean, this is a challenging time, but we will get through it. There is hope at the end of the tunnel. So, hey, catch you on the flip side.